here we are given a graph of g of x, and we're told, given g of x is graphed below, graph the function f of x, where f of x is equal to 2 times g of 3x plus 1 minus 1. The first thing we should do is identify our parameters. So I'm going to actually write out all the parameters here. The a value is out front, and that's 2. And this represents a vertical dilation. So we're going to have a stretch. This thing's going to get larger in this direction. Second parameter b is 3. And remember, things that happen inside the function notation happen opposite to what we expect. So instead of this being a horizontal stretch, this is going to be a horizontal compression. It's going to get narrow by a factor of 3. The third parameter, c, is a move to the left, again because it's opposite of what we expect. So our c value is negative 1. And outside the function, again, we see our last parameter, d, that's negative 1. And that happens exactly the way we expect. So this will cause a stretch vertically. This will cause a compression horizontally. This will cause each point to move to the left 1, and this will cause each point to move down 1. So let's just go ahead and apply these transformations to the points. I'm going to apply the first two transformations, a and b first. And I'll mark these and where the points go with a nice square box. Then afterwards, I'll apply the last transformations and graph the entire function in green. So this point gets doubled, its distance from the x-axis doubles, and its distance to the y-axis shrinks by a third. So it was 3 points away, now it will go to 1 point away. So this point was doubled and then compressed. This point will be doubled to 0 and then compressed to 0. So there actually is a point right there. This point will be doubled and compressed. And this point will be doubled and compressed. Now it was at 6, so it's going to be compressed all the way down to 2. And so this would be the function g of x if it was just stretched vertically and compressed horizontally. But we're not done yet. We still have to apply our c and d transformations, which means we have to move everything to the left 1 and down 1. So this point was at negative 1, positive 4, so it'll go negative 2, positive 3. That's where this point maps to. This point maps down and over, this point maps over and down, and this point maps over and down. And so now we can draw our final graph. And this green function would be the function f of x. It's been compressed, stretched, shifted over, and down.